We're going to find the limit of x sine of 1 over x squared as x approaches 0. I'll leave a link in the description to a lesson on a very similar limit where this x in the denominator is not squared. We could solve this problem the same way we solved that one, but I'm going to do this one just slightly differently. As is often the case when we're trying to evaluate the limit of some trig function multiplied by some other function, we're going to want to use the squeeze theorem. So we begin by using our knowledge that sine of anything, certainly sine of 1 over x squared, is between a -1 and +1, right? Sine goes between -1 and +1. Doesn't matter what's inside of it. But of course, we're not trying to prove something about sine of 1 over x squared, we're trying to prove something about x sine of 1 over x squared. So we should take this inequality and multiply the whole thing by x. Then we'll have a statement concerning the function that we're actually interested in. However, since x is approaching 0, there are two things we have to consider. X could approach 0 from the right and be positive, or approach 0 from the left and be negative. So we have to consider what's the inequality going to look like if we multiply everything by x and x is at least 0, and what if we multiply everything by x and x is negative? Well, if x is at least 0, then nothing changes. The x gets distributed through the inequality. We have negative x is less than or equal to x sine of 1 over x squared is less than or equal to x. However, if x is negative, then the directions of the inequalities will all switch. And so we'll have negative x is greater than or equal to x sine of 1 over x squared is greater than or equal to x. We can condense these two inequalities using some absolute value, because in the first one, notice that the biggest thing is x. And in this case, where x is non-negative, x is the same as x's magnitude. Similarly, down here where x is negative, the biggest thing in the inequality is negative x. And since x is negative, negative x is the same as x's magnitude. So in either case, the biggest thing in the inequality is the magnitude of x. And similarly, the smallest thing in both inequalities is the negative magnitude of x. Here, where x is non-negative, the negative magnitude of x is negative x. Whereas here, where x is negative, the negative magnitude of x is just x. All that is to say, both of these inequalities can be captured by this inequality here. X sine of 1 over x squared is between the negative magnitude of x and the positive magnitude of x. And now we can apply the squeeze theorem. We have our function x sine of 1 over x squared bounded between two functions. So we evaluate the limits of the lower function and the upper function as x approaches 0. The limit of negative absolute value of x as x approaches 0, well, absolute value is continuous. We can just plug in 0, and of course, this limit is equal to 0. Same thing on the right. The limit of the absolute value of x as x approaches 0 is 0. So, by the squeeze theorem, our function must be squeezed between these two functions. Since they're approaching 0, our function must also be approaching 0. So the limit of x sine of 1 over x squared as x approaches 0 is 0.
Reindeer to pick me up and slowly get to know me. We'll unwrap each other until we're never lonely.
Is it okay?